Now we are going to discuss about the convergence of a power series. Well, before that I should mention something. Well, for a power series, it is not a must to start the power series or start the indexing at 0. It is not a must. Okay, you can start the indexing from whatever the number you need, but still it will be a power series. But as long as this is positive or 0, it will still be a power series, right? So the only requirement is that this is a non-negative number, right? Because if it is a negative number, then this will be a negative power, so you will get something like this, which is not in the power series notation, right? So it is not a must to start from 0, but you can start from any number which is not negative, right? Okay, that's something I should have mentioned in the definition, so keep in mind about this starting index, right? Now let's move back to the convergence of a power series, right? Convergence of a power series. Right, let's take this one as the example. Right, now remember, power series is something like this. Okay, this is not required to start from 0, but in this case, for this particular example, they have started it from 0. So in the general notation also, I am starting the indexing at 0, right? Okay, so here is, since this is the generalized notation, if we are going to relate the terms for this specific example, then Cn will be the sequence of n factorial, right? Cn will be the sequence of n factorial, and A will be equal to 0, right? Then only you will obtain this specific example out of the general notation, right? Okay, now remember, in the previous week we did like during the previous 2 weeks, I guess, we did something called the convergence of a series, right? So if we have some sort of a series, we defined a certain thing called convergence, which is basically defined through the sequence of partial sums, and then we discussed different methods to identify whether a given series is a convergent series or not. Okay, and one of those methods is the ratio test, right? Ratio test. What do you mean by the ratio test? If the limit of an plus 1 over an, the modulus of this one, if that is less than 1, then we say that the series converges. Okay, so if we are going to interpret this ratio test in our power series, let's see what's going to happen. Okay, so in our power series, this is the term that runs through the sigma notation. So it's like this is our an in the series, right? So all these terms together will form the general term of the series, right? Now remember, you have a variable here, right? Then if we are going to apply the ratio test, okay, so if we are going to apply the ratio test, then the anth term will be n factorial times x to the power n, and a n plus 1 will be n plus 1 factorial x to the power n plus 1. Therefore, we can see that if we compute the limit, then it will be reduced like this. Remember, n plus 1 and n factorial and n factorial will get cancels out, leaving out n plus 1th term, because n plus 1 factorial will be equal to n plus 1 times n minus 1 times likewise, and in the denominator you have n factorial, and that is this term. So all these terms will get cancels out with the n factorial term. So what remains will be the n plus 1th term, and remember you have a modulus sign as well. Okay. So whatever the number we have as x, okay, whatever the number we have here, this limit will go to infinity, positive infinity, because of this modulus sign, right? So that means let's have an example for x. Let's take x equals 10, right? So if you use x equals 10, then this limit will be n plus 1 modulus of 10, and that is equal to infinity. If we use x equals negative 10, then again this limit will be n plus 1 times the modulus of 10, that is equal to 10, which give the limit as infinity, right? So simply whatever the number we use here as x, just forget about 0 for a moment, right? So except 0, whatever the number we use as x, it will still give the limit as infinity, right? So from the ratio test, it says that the limit is greater than 1. In other words, from the ratio test, it says that the series will diverges. Okay, so as a result, what we can say is this series for any x, which is not equal to 0, if we use any x which is not equal to 0, then this series will diverge. Say for example, if we take this one, this series will diverge. Now for this particular case, we don't have to use any theorems to prove the divergence, because we have already obtained the result for a more general notion, right? So from here itself we can conclude that for any x value except 0, this limit will be infinity. So from the ratio test, for those particular x values, the series will diverge. So if we are given with a specific example, then at once we can say that this series will diverge, right? Because you have the result for a more general case. Okay, right. And let's do another example. Sometimes you might get confused with these things at the beginning, right? Just bear with me for a moment. When we are doing some more examples, you will be more familiar with these concepts, right? So in the next video also, we'll do some more examples.